Hello, ladies and gentlemen. Welcome back. Yeah, just welcome. Let's see. Oh, fuck. Will it work? Yes! It fucking works. Actually, my camera angle is a little bit fucked. Welcome, everyone. Reorganize a little bit of the stream now. Maybe I should really quick flip myself really quickly. Oh shit, I can change the lens. The thing is, how would that work? I don't know. Got myself a little bit there. Oh, that's pissing me off. That two seconds. 2 seconds. I need to really quick check. Do one thing real quick. That's pissing me off. Which one is it? It's this one. What width is my 940? I need to fucking 940. Wait, yeah. There. Width 640. Oh shit, that's fucking big. It's not 640. You're just not 640. Are you 360 maybe? I'll incline more to that. Oh. That's because. Yeah, you are 640. Am I reading wrong? Resolution. I've also scaled myself down a little bit. That's also maybe something. Alright, time to test random numbers. Nope. Should have done this before stream, but now we're here. Okay. That's probably by like 15 pixels. That's good enough. Okay, so today we are going, as the stream also says, why won't Discord actually start? Should I be worried that Discord doesn't want to start? I want to at least have Discord a little bit. Actually, I've just realized something. You guys can't see shit over here. Again, should have planned all this out before stream, but now we're damn fucking here. I think you should be like 300, 400, 600, or 75. That should be good enough. And let's just like throw you. Let's decrease the height of you. Let's do 400. Should have done all this before stream again. I know, but I don't fucking care currently. To the left. By like 360, I guess. And I must. Just the 20s. fuck that. Let me just move you like 400 pixels. That's good enough. Shrink you a little bit. Like 350. Means I need to plus you by 50. That is then 725. Do you only need to be like 200 pixels? Oh, but then I need to. Should probably then scroll down the. Okay, this is gonna go for now. I need to tweak all this later. But here we are now. I need to really quick also make my turn. Right there. Terminal. And scroll this one up. Goshi. So here we are now. Back yet again to where we have always been. Now, last night I did some things in form of paging and whatnot. Oh no, so I don't know, did I actually get that working? What did I actually get working? I got that working, yeah, I got it. Yeah, I did get everything working there. Yeah, wait. Yeah, I did get the program working. Did I? Yeah, I did. Sorry, but my OCD just can't help it right there. $460. Let's just move this 60 over there. And that hits. Damn, my OCD couldn't just handle that. I need to do something about all that later. Hey, to you. Let's see, does this work then? Who the fuck is slamming doors all over the place? Like that? Okay. Yeah. Hello to you. How you doing? Okay, what was actually the problem that I ran into? I had a problem. What's that? Let's see. I remember I had a problem last night. I just don't remember what it was. Oh, boot looping. Well, of course. What else should it be? Fun fact, it has something to do with paging. I fucking hate paging. I hate the MMU. God, I hate that. Did you get anywhere with the 16 You mentioned you might take a look. All right, yeah, fuck. I got distracted with with a little bit of with a thing called paging, and also just simply getting user programs to work, which I've now done. Now user programs can be ran here. Paging is fun. Yeah, very fun. Okay, let me see. So it's just fucking up. Good. I would have hoped that like paging would be as easy as like just running one instruction and enabling it, and then it's done. But now you have page tables and page directory tables and whatnot. Yeah, only if. Well. Should I just steal some? Should I just borrow some code? Not steal. We don't steal. We don't steal on this channel. I think. Should I just steal some code? Just to get it over with. And I can. Yeah, I'm gonna figure it out later. Then. Should just. Paging is nothing more than splitting a 64-bit. Not 64-bit, only 48-bit, but okay. Into multiple 5-ish. Yeah, I know. I know all the theory. I know all the theory about it. It's just the hard part is to get it down and actually make it work with the allocators and whatnot. Each page table is a level. And their names are all stupid. Well, you don't have to tell me that 2 times. You don't have to tell me that twice. They could have come up with more simple name schemes. But they didn't. Now, the only thing that's maybe a little bit good about paging is that at least you have things. Don't get me. I've actually seen some fucking like code for ARM, and yes, it is stupid and nonsense. I think yeah, we're gonna. No, it doesn't. Is this an ARM operating system? Just to say this is an ARM. The page table entry properties are all scattered and weird. Have you heard of the GDT and IDT in some way, shape, or form? Maybe. Bro. Instead of sitting down at one point. So damn fucking simple. Like you have fucking flags that like. Okay, you have a flag. That's the lower part of a byte. With the upper byte, that's just the rest of the limit. Oh, and also the whole limit. That's like at 4 different places in the GDT. In a GDT entry. So you have to do so much fucking bit manipulation. I hate bit manipulation. Yeah, apparently yes. Can you hear that? I hate the bit manipulation. God, I hate bit manipulation. Literally, the, the one thing did do right was their interrupt table. Ah, I haven't actually seen. Like, the only interrupt table form I've seen is the. Did you come in at the 16-bit and get extended to 32 and. Or was it a. The GDT come in a. It was. The GDT is a. Is a 64. No, wait 2 seconds. Now I need to really quickly look it up. 2 seconds. Global descriptor table. Yeah, on 64 bits, it is a 127 bit struct, and in 32 bit mode, it is a 64 bit struct. And yeah, here you can see you have the base, 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 and here you have the limit and limit right in between the flags. I hate it. That's actually. Oh yeah, that's pretty much the same. Yeah, it was. Okay. I just said that in the most fucking Danish way possible. Okay. I just said that in the most fucking Danish way ever. Fuck. Oh yeah, so what should we take from. I've already taken. No, you don't have paging. You have paging. Yeah, we're gonna steal from this dude. Oh, I'm borrow. Yeah. We're gonna borrow from that dude. I think. Actually, let me just really quick go into my projects instead. And just paste it into there, yeah. Get loan that dude. Code dot. Memory. K heap paging PMM. So it's somewhat the same structure actually as mine. Except I have I actually have a total. No wait, just I have a totally different structure. Align and get physical address. Well, you could do that. Calloc. Yeah, we're gonna. I already have functions for all these things, so I already have wrapper functions for all these, so I don't need to do that. I'm fucking glad of that. Yeah, like I pretty much have a wrapper function for everything, pretty much. If I can make a wrapper function, I make a wrapper function. PMM. OS dev in its finest. Wrapper functions. It fucking sounds like I'm saying wrapper functions. Lock me in a wrapper room of rats. Yeah, let's just copy this and like just yeah, just take some of that and nobody noticed, right? PMM. You're the new one here. Memory allocator. We don't really need that one anymore. No. Yes, I have already made a... I have already saved everything within the... So I can just transfer back if I do something stupid. Which I will. Don't worry. At some point I will do something stupid. It's just a question of when. There. Paging. And k-heap. And like any old good law-abiding dude. That's the only thing that I pretty much can do now. What's the issue, by the way? It's an issue mapping dense virtual memory regions. I think, like, at least what I think the reasoning was mapping use page table entry or mapping. I was mapping with a continuous page table entry. And the issue was that it was boot looping / restarting on me. Just like it would start up, it would start up, go through everything until you hit the init function, and just restart. I would guess some kind of exception, hidden exception or something like that. I don't fucking know about, or just the CPU says, yeah, I don't fucking know what this is. I'm more inclined to the second option. My having triple fault. Probably, yeah. But now, hopefully at least, there'll be a system that I at least kinda works. I hope. Yeah, what do you need out of system? Is it those things? Well, those we can deal with using that. I guess it was just something like that. Did that? And then there was also some other fucked up things there was about that whole thing. So I just decided to kill it now. That seemed easier than debugging something that was boot looping. The ISR. Some useful macros. You don't say. Oh, these functions could actually maybe be a little bit useful. And let's just throw them into here. Those two functions those two structures should have some way, shape, or form. Okay, time for these ones. local things. I don't want like that. Ah, I am now all of a sudden glad that I actually have made the. I should have signal. All right, yeah, that was the thing that I didn't have. NVGA. QEMU. Yeah, what can we? Yeah, that's probably a debugging thing. So, and actually, let's just like do this. This is easier than just doing everything else. Load memory address. Okay. Have it local to there. Log debug. We need to name this module. That's not a that was not a definition. Module. Let's just call this paging. Now every single time we meet this, we should replace it with this. And then I need to then go ahead and mark these as, I'm gonna mark all of them as, many of them as critical. Free page. It's probably important that there's a free page. That's a long time since I've last had the seen fucking. Hey, page fault. Oh. I kind of already have a page fault thing. So actually, maybe it is a good idea to really quickly have that. Is it? It is probably a good idea. Let's set critical to this. Let's make let's make those ones. Should make maybe yeah, we just should probably just make these infos. Just stumbled over all my fucking words there. That is fucking great. There. And there. Oh, I did not have one of those. Okay, so what we'll then go ahead and do, go under the ISR, go under here, and say thank you for this. That should be it. Except for these two up here. That was it for that file. Next file. Actually, get rid of VGA. We don't need it anymore. Oh, printf. We have one of those, kinda. If I go on the printf drivers and say printf, that should be something like that. Alright. Actually, did you actually have? Holy shit. Call me surprised. Actually surprised. Um, holy. Holy shit. It is beginning to be hot here in Denmark. Somewhat I hate it. I hate it somewhat. What? Oh, down. Warning. Don't I already have? I do think I remember. Not PHP. I don't want PHP. Fuck you. I can't even do PHP, but okay. That was not quite what I was thinking, but okay. Sign in your Visual Studio subscription benefits. No thanks. No thanks. For fuck's sake, I'm not even coding in fucking C sharp. I don't need fucking I also don't even have fucking Visual Studio. I would love to if I had, but sadly I don't. Alright, so what should we do here? It has something to do with this thing here. Let me actually really quick read up on it here. Oh, that's a UART. A serial port. UART shit. Well, I don't really use UART. It could probably actually be a good idea if I did. But I don't. So I'm not gonna, no, so nope. Just delete that. Running out of blocks. That's probably an error. Quite possibly an error. PMM. Physical memory management thing. Of a jig. Log. Was that really it? Oh shit, that's quick. A heap, kernel heap. I'll at least get so. Your heap is now empty. Well, I don't know what I should do with that information, but my heap is apparently empty. I don't know why. Also, get those fucking backslash n's away from my code. Don't know what half of all these things they mean, but I'm gonna run with it. Is this... I do believe I... Yes. Okay, let's see. Let's see if my injection of code just works or not. Oh yeah, that makes sense. that kind of makes sense because that file that doesn't. I can fucking talk. That would probably now be in kheap, I think. If I would guess by anything, everything should probably then be in kheap. And also, oh, debug print. Gonna throw that one down. Yeah, we're gonna keep that one. Just malloc for align physical. Okay. Okay. 0, 0, I would guess. Gonna keep those. Wait, let's see. Okay. Under paging.h. Paging.h? What? Under simple resture h. Restures. Check. And paging.c. Oh, on the main course. That should then improbably. That should kheap maybe. Let's have a look under K heaps init wrapper here. And look under here. And look under inits. Paging inits. So I should call all these int. Oh shit. Fuck. Alright. It there. Is paging then enabled? Yes, it is. Gushy. PMM. Memory size. Do that. And then K heap. Guess this will work. Kinda. You know what? I am going to do a clean. And then I'm going to run it all here. So I can quickly jump. Or not. But 52. Signal.c. From signal.h. Why are you giving me an error? Find yes. Drivers device.h. Drivers device.h. That's fucking weird. Unknown type name. Why the fuck are you saying that that's an unknown type name when you literally have it already? If I would guess anything, maybe then we'll probably have to be like something like actually there would probably have to be something like compiler precedence, maybe. At least that's what I would think. Right there. Remove that. Well, that seemed to work. We'll just do struct there. Are you just now fucking flagging all my fucking files? Or all my types? That could actually be something fucked to do, but okay. Okay. Probably has something to do with the... At least that's what I would guess. Compiler precedence. System.h paging YouTube up here. Do we even have a map.h? Yes, I do. That's fucking weird, you could say. Declared inside parameter list will not be visible outside of the declaration or a definition or declaration. It's right after sites signals. It's right before. Okay, 2 seconds. Let me really quick do some debugging. Not debugging, but very quickly. Compile down. FS disk C. Do I even use that? I had actually totally forgotten I had that. Oh, just accidentally move project into the HAL. That's fun, great. All right, yeah. Now I need to. Down. For some reason. Oh, that's why. Good morning. Disk.h and let's see. Do I even fucking use disk.h as C? I don't think I use it there. Do I use any functions here? Or just general? Nope. 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 None of the structs I at least also know. And here I specifically don't. So need those two. Is this one standard IO? Compile FAT32. I know technically it already is there, but just in case. Just in case. Back. I don't need to find now. What other could it? For fuck's sake. It's because that I apparently included the debug.h in here, and it fucked everything up, so I don't fucking know anymore. Not the fat one. This one. Oh. Now it could actually be a... I've made a lapse of judgment. I can see that. I have made a lapse of judgment real quick. I do believe I can see that, so I'm gonna quick go to restore these three files. The reasoning why I'm restoring those three files specifically is because in here we are literally we are initializing nearly everything out the heap and some other things. Plus also then I can compress all this into just one. Let me just copy, paste, take this one, and I really need to look at this. I actually love that you can open script files like this. And what we're going to do is that we're going to take this, slap it in here like this, take all this, page size there, and there, check. And now we have all the variables that we need. Base, heap, end, and the heap max. As simple as that. That also does mean that we now need to a memory allocator right here. And all of this we don't really need anymore. Alec, right now. Just throwing the... Oh. Fuck that. I may have missed a comma, but fuck that, I don't want that. We don't need to do that. Or that. Now, here comes the thing. Now this is my AHCI driver. Why I kinda had some problems, as can be seen by all the many things here. Now, if I'm lucky, which I'm probably not, all of this will just breeze away without any care of the world. Now, if I'm not lucky, funny enough, it will not happen. And secondly, GMPC. I never thought that it would go ahead and fuck anything up there. And I'm gonna just throw you into paging. So now, there's still two things. Okay, do we even use these macros? I do. Then what will them do? In the files that actually need it. Actually, we could... We could just throw it into the... into here. I guess. Actually, maybe not. And we're just even going to define it all over the place. No care in the world. Please work. Okay, what? This doesn't fucking make sense. I shouldn't have, like, those ones here in any way, shape, or form. But apparently I do. And the worst part is that this is only like... Actually, is it... I don't have it. Oh, damn it. It would have been fun if I had it. Let's just throw it into here. Going into some fucking old ass libraries just to... Yes! ATA read? Excuse the fucking me. What the fuck do you mean? Don't you have ATA? You should have ATA. You don't have ATA. Okay, that explains a bit of it. But not a whole lot. PVM. You now don't have debug. One of the greatest header file stuff ever made. PM we no longer have. I have deleted, thank you. Okay. Keep. I should just make you into like void pointers. Maybe. Will that work? That did indeed work. And we'll do this. Let's just error, not error code. I think you're using different error codes than I use, so this will be. I had to head off. I have to head off. Okay. See ya then. Okay. Any place in here where Rex is being mentioned, we'll replace it with this. And faulting address. ASM, 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 ASM. Register handler. Okay. And what the fuck do you say that that's the not good part here? Should I cast you into being a UN32 pointer? That goddamn fucking worked. In some way, shape, or form, that fucking worked. Conflicting types. The real relic. Conflicting types. Where? Okay. Conflicting type. Assess. That's because it is just Let's underscore as this, thank you. Okay. Debug doesn't fit in. I did. That's fucking weird. Like, apparently it needs to be specifically an unsigned long all the time. I don't fucking know why, but here we are now. And now, what is wrong here? You inferred to into a pointer type. Void pointer type. Oh, that means then that there is a. Just close all this up again. Thank you. There's linker errors. Woo! Not all because I had fun. I've totally forgotten that they existed, but okay. Um, kernel 3. Yeah, that one's good. Like, when do we actually like void there size t, not size y, size t. Multiple definitions of malloc. First defines there, but it's also defined in kheap, for example. But shouldn't be in kheap.h. No, because here we have thrown everything with malloc out. The real malloc function. What we'll do, we'll just do this for all the malloc functions here. And same with free. Will be turned into, what did I say? I said underscore before. Okay. Let's just move up here and do this. React. Just like that. Multiple definitions of kernel. We have one definition right here. Underscore. Actually, this one can just like be made into malloc, kmalloc again. What the fuck do you mean by undefined reference to? Oh, it's another file, so that's huh? Oh, that's one. So which one is the correct one? That's that one. That's with the underscore. And temporary page directory. And let's just throw that into the linker probably. Let's just throw that over to linker to fix that. A temporary. Actually, defined in so where Okay. Because yeah, then it's in here. I'll just move you down here. This is going to end up being messy, don't worry. Why do I define... Why can't I define you? Well, I guess. So, okay. Because in my linker script right here, we have this. These are some things that I made to just more specifically go ahead and actually allocate things. Let's externally get this in here. And now instead of doing like this, let's make a definition right here to be, yes, don't worry, this will look ugly as fuck, but actually, how the... I think I did something like that. Why did I do it? I did it in page. I think I did it in page.c. Now that just becomes the question, why the fuck did I put page.c? That's now the great question of everything. Paging. Oh yeah, I did it, for fuck's sake. So right here, as you can see, oh yeah, it was a uint there, external uint array, and then you can see here how we did it. This just seemed to... Oh yeah, wait, two things. I have not even thought about actually being able to assign. I should just say no to this, I guess. Yeah, fuck it then. Now we just need to find an area in here about the size. How much? What's the size here? That is 1 kilobyte. I could probably... I'm gonna page it into my kernel, my main thing here. Don't ask about that comment. Now everyone wants to ask about the comment. And if I then say make times, that is wrong. How the heck am I doing time? Oh, okay. That is it because it needs space? If I do it like this. Non-constant argument supplied. Oh, that's why. Let's just sit right up here, right there. Undefined reference to end in PVM and kernel. Define the linker. I would guess it's something like, yeah, okay. Okay, I have one of those. I do definitely have one of those. That's just called underscore underscore int, but who counts? Now what we then can do probably is that we then can say define why the fuck are you defining it like this? Shouldn't you define it something like this? But anyways, we can then say end here 32 underscore underscore end. Oh, it's there. Okay, so yeah, we can just use underscore underscore in, because then we don't even need to do that. If I don't delete all that, look at that, it's gone. Now also PVM. Here we also now have an end. Let's just say underscore underscore end. And need to catch my breath there. Let's say same thing here. Now everything should work. Well and truly, fucking did. Okay, let's clean everything. So we then can go in here and run it with everything included. Oh, now you can see this, right? Now the way that I have dealt with it, because I do not know how to deal with things, it's just this. That is how I've been dealing with them. I should maybe move the QEMU, like run things here. Is this good for everyone? Oh, it's actually fucked. I don't wanna fucking like. I'm at a program header, offset plus size, file size, negative 700,000. File size 12. So that must then be 120,000. Maybe if we check kernel.elf. It is at least 1.5 megabytes. Oh, that means that we've gone up to the megabyte error. Oh. How would the disk then? How does actually then the disk do for itself properties? Yeah, wait. We have enough space for everything. We have enough here. But that's one thing that I've been thinking of doing. And that's to, instead of having an kernel.elf file, then pretty much try to make this into a raw binary file. Because don't actually think that we use the elf like really, like I don't think we like really use the elf features if you would. Yes, of course we are extracting some things and all of that. Getting some offsets and all that, but I don't think that we are using improper like some of the elf features. So what I'm gonna do now is that because I watched the video at some point, I usually do that sometimes, where you can make an elf file into a binary file. Now I can't remember what the fuck the command was. I686 obj copy maybe? Read hell. If I say obj copy and dash dash help, then we'll get a whole bunch of things. ZPE file, okay. Is this to make a PE header? Or to make a PE file, aka a Windows executable, pretty much? No, wait, I can. I think Carve also did this. CarveOS also did it. I just thought there was something up there. Oh shit. All outputs. What is the output? That's that. It was at least not there. Make file. Just define everything. Okay. You could do that. Let me see. So executable. That's OS there. Well, that gives me a whole lot of fucking thought into what the fuck it is. I wanna know. Level X OS, yeah. Let's go on the kernel here. Actually, maybe if I go on here. Mount start assembly bkernel. Link levelOS.bin. Let me just really quick try to find the actual video and project. Oh, there. Found it. First thing. It was redact OS. Couldn't come up with a better name myself. Right here. Redact OS. Now if I look into the makefile real quick. Zoom in. That's all we need to then go on the kernel. It actually has a thing like me. A file structure like me. Here. Yeah. Obj copy. So it was object copy. Where we say output as binary, I'll guess input and target. Dash O binary. That was capitalized O. I don't even know if I actually can do this without being in sudo. Build slash dash slash kernel dot elf into dot slash kernel dot bin. Something happened. Yeah, we have a kernel dot bin here. With some of the things extracted out, and we can see here. We got it. Now I do not remember I do not remember anything, like I don't fuck. I don't remember if the first instruction here is my actual first instruction, but I think if that problem comes, do we have a 10? Nope, we don't. But that's probably not. Alright, let's throw all of this into a x86 converter, because I don't want to do binary by hand. Just get flashbanged. 66B8. In the binary portion. In 66 10 0 with 2 hits. Which one do I want to believe in? 8E. D0. B8. Well, that was B8. Right down here. This is the start. So I think we then need to like change our kernel start, I guess, here is equals to that. And now then, if I set the section to that, to this, and then I run this, we'll have to hope and see if this actually all works. Okay, we got something here. I just get thrown down even more. Into some kind of text section or something. I'm really going to clean and then because at least what I know at least is that the linker script should say what is being outputted. Actually, we don't even need to do all that. But anyways, here, yeah, get shoved into the fucking bottom of everything. Like, is it upside down or something? It could actually be a little bit fuggy if it actually was. What if we make it here? This time we'll just say kernel and -b. Did I remember correctly? It was object copy. Yeah, really. Now if I use it here now again, we're still here. This is not very good. We should like be at the very top of everything. At least that's what we should be at. But yeah, we are apparently not. Is there something about linker scripts that maybe? Let's change all this to be kernel.bin. And then the output should not be kernel.bin. That should be, first of all, kernel.elf, because I still want to be able to use GDB. Now in my linker file right there. No, not linker file. Will just be in here, stay in here. And then if I then say, I need to go into the configurations. Oh shit, I've been into the fucking configuration more times than I even can count, pretty much. So yeah, if I say obj, for example, object copy, and then here, target obj, target object copy. Now why are we using this? Because then I don't have to change anything pretty much. Now, if I then use target OBJ here, say that the output should be binary. Say that the input should be kernel.elf and the input should be input. Yeah, input should be kernel. Output should be kernel.bin in the same exact directory, by the way. And then we say we have created kernel.bin. In here, we'll now have to delete both of them, both of the files here. And now, let me close my terminal. Now, if I then go ahead and do this, we should see a kernel.bin. And now again, okay, if I just take all this, oh, I think it was full. Still at the bottom, which is not good. If we want to be somewhere, we want to be at the very top, so we don't have to think about anything. But it doesn't want to let me do it. Is there a way I can just force a file up to the top? Maybe. Anyone who is experts at linker scripts, please do come forth then. I pretty much need you now. So if I say maybe plus equals to like 4 whole fucking kilobytes. Oh fuck, oh. I can see dots. I kind of want to know how that fucking looked on stream, just like boom. It's like a flashbang right in your fucking face. Because now we have 4 kilobytes here. Okay. GCC linker scripts. OSDF has something. Oh, there's even also multiple entries. That's cool. Setup. Oh, we could set a setup file, I think. Setup takes one argument. It is which file you want to link at the very beginning of the executable for userland. Oh, userland programs. This is usually okay. Damn it. Damn it. Sections. Text start. Kernel base. Oh. This script tells the linker to place code from .text section in setup.o the beginning, at the beginning, starting at logical address kernel base. Okay. So we're starting there, we're saying there. Is there somewhere I can just say set this at the very start no matter what? Pretty much force it to be at the start. Lego script. There's a fucking lot of examples. Linker scripts. Force at force simple at start of binary. Entry.o, that text, and then the rest of the text, I guess. If I do that, maybe. That means though that we need to then expand everything here. Like start text. And then we're gonna say main asm.o bj dot text. I hope this will work. If it does not, I'll cry. I really hate that I need that, like, something fuck it just happened. Probably something in here. Yeah, could not find. Oh. Yeah, because this means like the rest, I think. If I didn't try to just do this, could not find there. I guess it's because that they don't think someone would actually like do something like this. So if I go under build slash, I don't care. I'm just even going to do debug for now. I'm just even going to force it to be like this, at least for now. Could not find slash. Do I need to go from fucking home? Huh. So maybe, okay, I'm gonna try to go from home. Home slash projects slash PSOS. From just generally slash from root. I think that's how the path is, isn't it? Slash home Slash home bien biz. Projects, build, and so on and so forth. Huh. This function start. Multiple definitions of start. Multiple definitions of start. You say. Where else do you have a fucking definition of start? And yeah, this just yeah. How can I do this? I just thought of one thing. Yeah, let's say, for example, that boot, the text, like in this example, pretty much set the, and then I set the symbol to be there. Oh, if I go up, it's there. Yes. And I fucking got it. Oh, my arm. Fuck yes. Well, we can also delete this. That's just some waste space. Yeah. Let's now go into the image, make image. Time to clean up my Python. That bin now. Holy shit. And so yeah, now we have this. And now do people wanna hear the worst part? Now I have to go into 16-bit. Woo! Absolutely excited about that. Now, why do we need to go into 16-bit? Well, because now it's no longer called the boot slash boot slash elf slash boot slash kernel.elf. Now it's no longer called that. Now it's called slash boot slash kernel.bin. And so now we don't need to read from elf linger. Why am I talking Danish? Don't. Let's then go into the bootloader slash stage 2. And let's find something. Let's find some kind of read function maybe. Of course we have read sector. We could of course do that. We could hack our way into the fat function and just read all that. Which we are probably also going to do. Or we could do something else fucking crazy and figure it out ourselves. Or maybe actually we could also inject just inject symbols in from build time. But we're not gonna do that. So We have a few options now. And the worst part is, again, we are in fucking 16 bits. 16 and a half bits, kind of. We're kinda in 16 bits, but also not. But also we kinda is. Yeah, it's a bit mismatched. So now we need to figure something out. We need to figure out where we are, what the fuck it is, and what we're doing. So let's do some things real quick. So now I have so I know here in the bootloader, in the stage 2 bootloader for me at least, I have a pretty good fat API. So let's try to use that for now at least. So let's open. Now the disk in this scenario here is a partition. So if you see disk in arguments, that's a partition. And so now we then need to go ahead and do this. Now this doesn't, no wait, actually it does return something. It returns a that file. That's our file descriptor. Now we have technically found it. Now what is actually in this one? In here? Well, we have a size, we have a position, when we can see if it's a directory, and we have a handle. So we actually have a few things that we can do. What do we want to do? Well, I think we want to really quickly read the size. Check that out. Let's do that. Extracting the size here. Now, why do we want to extract the size, you might think? Well, that's because to figure anything out, we both need to get the amount that we should read, which in our case is the file size again. In this case, it was from the header. Okay, then we should read it. Check about something if the amount we should read is the same as there. Now, if that is not, if that all that goes through, then we should decrease the amount of the thing that we should read, and seek. And all this happens inside of a while loop. Let's do this. Whilst. Let's really quick do some things here. So we have our size. So yeah, let's really quick do this. So size. So if size is above 0, if it's under 0, we don't have anything to read anymore. Now, I'm pretty much going to just copy some of this pretty much. So what we should read, that is a macro in min-max. I'll probably move all this into a designated like file, something like that. Now let's go into memory, load size. Then we should read. Let's really quickly make a variable here for the BSS to deal with. Now read. Here we want to do our classic fat read using our what the fuck is that? There. Using our partition. The file that we want to read from is of course fd. The count is the should read, and the buffer. Now let's for now at least say load buffer, and then we'll make, I guess, a uint8 pointer load buffer equals to here. Now kernel entry here. Then let's do a pointer here to there. Now this should be good enough. So if read is not the same as we should have read, then we'll throw up an error saying failed to read program data. Remember, always close your files. And then we can't really return false. So what we're gonna do is to say go to end, which if you don't know where end is right here. The backup system, if you would. Now we wanna minus this with the amount that we have read, and the load buffer we should plus with the amount that we have read, and this will continue until we have read everything. So this is pretty much our seek, pretty much. And so now we should have everything, I guess. What's the cloud? Okay. Let's do a clean. Make stage 2, because I knew that I had some that would have some things. Now actually 2 seconds. You are set to something. The entry here is set to something, and it's set to the program entry partition. Not partition, position. Now, what is this for us? Well, I'm glad that you asked. If I go under and try at least to find my linker script here for the kernel, we can see we have a physical to there, which is to the user data, and then we have an address here, which this, ladies and gentlemen, is our load address. I even also think I actually also have it under one of the, I think I also have it under one of these files. Because fun fact, all of this uses memory mapped stuff, so we kind of need to. Memory defines here. Memory load kernel. Memory kernel address. That is correct. Now let's set this to be our kernel start. And now we should have everything done. So now it's just all about saying clear and then make run. I'm actually a little bit nervous. I am a little bit nervous to see if this actually works. If my coupled together code actually works. Okay. It works. We can clearly see that. We do get into the kernel. Then we could go up here to start. That's maybe a little bit too far up. Here. Doing all this right here. You can see we are setting the GDT, which we are only printing in this color in the kernel, so we can only have this in the kernel. We can only be in the kernel right now. And yeah. Do all this. And now here we have a problem. Now we're no longer in here, so let's just say kernel. And now we have a small problem. Right here. We have apparently ran out of blocks. In this case, I do not know what to do. The only thing that I know about right now is that this right here is our start address, or is the total amount of memory that we have. The rest, well, I don't fucking know. First free block. Now, I want to really quick check. Where do we set this? Right here in PMM. I was just about to say PVM. It's PMM, which we do also initiate. This is why I hate doing. This is why I hate doing these things. Now here, yeah, because here we use the bitmap, so okay. At least we don't. At least now we only boot loop. I guess that's a good thing. Now I think also there should probably also move all these ones around. Maybe. Yeah, we're gonna really quickly move this one up here and then enable paging after everything, and we need to do an Alt F4. Totally forgot how to do an Alt F4 right there. Okay. Yeah, fuck you, ATA. We have a bunch of invalid reads. Now I do know what that address is. Let me quickly do a run now. Immediately Alt F4 out of there. Now we'll set the GDT, we'll do all that, we'll get the memory and invalid. It's hard to be. What you down? Complete init. So video init, set cursor, GDT, and here. PMM-init. That's the first one. PMM-init. Which here apparently does this. Why? I do not know. Oh shit, it's literally in here for you. Yeah, right here. Damn. Well, then that probably means that I need to actually use these. And what if I actually use... What if I say this? Yeah, don't even ask about this. Don't even ask. Okay, so what we should now be able to do is that we should be able to boot loop. Fuck, that's fucking great. I've always wanted to boot loop. So if I just do this. I should in my main. That was math. This is main. So after all this, we should see init devices. If it goes through, now I already know that it won't go through, but you can hope. All warnings. Oh fuck. Oh. Yeah, yes, maybe read next time. Or fucking maybe fucking read next time. And please no backslash ends. It fucks up my consoles. Consoles? Huh? Console. That's not consoles. I don't have multiple consoles. Actually, technically I have. So what do we have? We have initializing there and initializing there. So our problem is in the paging. Would never have thought. I am really happy now. You can really hear that, right? In which part is it? If I were to give If I were to give my absolute honest opinion right now, if I should give my absolute honest opinion, it will be right here where everything fucks up. Flush. At least after. Maybe I should really quick actually just see. Now, again, this of course in my very own honest opinion. I'm saying all this. But looks who's right. So now I need to figure out what the fuck is happening. Set a clear PSE? What the fuck does that stand for? So it's that one in CR4. Okay. Let me really quick scroll up. x86 yeah. What did I say again? I said PSE. Page size something, okay. PC ID bit 14. And what just saying is that this one will be cleared. Now I'm asking, just all of like just curiosity, what happens if I just say no? All out of curiosity, what if I said no? Not really because it would change anything. And this is why I hate paging. People, this is why I hate it. This is what would actually happen if I didn't enable paging actually. So maybe try. I'm gonna try. I just went on with my day. I just said I just stolen. I've pretty much just now stolen a fucking like memory allocator. A perfectly fine memory allocator. Except for it's not. Let me get restart. Yeah. What didn't even make it past the PCI? PCI. Okay. So a thing that happened for you, like just thinking really quick. What is PAE? Physical address execution. Page directory base register. Oh, that's a thing. Page level cache disable. Physical address are assumed to be 0. Bits 3 and 4 are only used when without PAE. So then so we need to pretty much PA. Just saying, it was disabling. What were you disabling? You were disabling PSE without PAE. What if I were to then also disable that? So that's then PSE there. 1, 2, 3, 4, 5. 6, that's the number 2. That means then -3 in this one. We already have -2. That's then 4 plus 8, that's 10, that's A? No, that's not fucking A. That's 12. That's C. At least I think so. You know what? 3 here. And just invert it. Don't do all that magical stuff. Just invert it. Like, right there. Just invert it. Guess that fucking saved me a lot of fucking time. I like this, just I guess it's just like sitting here for a little while. It just really, yeah, I just need to really quick just like do something there. Now the worst part is that this is, I should be able to debug this actually. Oh, my is fucking sweaty. Again, it's beginning to get hot in here in Denmark. Alright. QMU, thank you. No, there should not be anything in that corner. I hope. We'll do my classic things. Set up everything. And now this was kernel start. Continue. Now we're here. Let's do next step. Next step. That was the wrong place where I stepped. Okay. Gonna try to do that again. Now this time, next instruction and step. Cushy. Next all the way through here. That one was good. And you, the troublemaker. So everything in here should work. except for, and on line 224, continue. Oh shit, debugging actually makes things slower. Fun fact. We are all sitting in excitement for something to happen. Even though I have minimized, still like holy shit, that's actually pretty funny. Oh, it's already done. Oh fuck. Okay, now go in. Lay gestures. I want this view, thank you. Here we can see a bunch of information about everything. Now, PC ID is already 0, as it should. And that's pretty much it. We can see CR3. Wait, what this thing is, wasn't it? Okay, fuck that. Let's get that. Hex 40. Let's disable that thing, which shouldn't actually do anything. Yeah, okay. Write it back. Read this one in. 17, aka 11. Set that bit. Something tells me that something didn't happen. Yeah, because they're both still 11. Okay. Well, it could do that. And now we're fucked. Isn't that just exciting? To try to debug fucking hardware? I fucking hate Intel. What the hell? What can we actually do? What can we do as of now? Not that much, actually. To be honest, we can't really do that much. We can't really do that much. Thank you. The only thing that we really can... Yeah, what? Should I maybe just do fucking paging later? Should then just revert back to here? Yeah, I think I'm just going to do that. So we are going to say... Yeah, so what are we going to do? Yeah, we're going to say scratch all changes. Which should put us back to the last node. Paging not did not work. Going back. The thing is, what we then probably should do is really delete all these as then good as new processes. And we need to do this at some point. But now everything should be back to where it was. We can delete these two files, those two files. And now if I run it, first of all, we should make everything. Because we've just like destroyed the whole program pretty much. Yeah, because now everything works again. If I really quick do print here, press it right there, we again are back to where we once was. So pretty much what we've done this whole stream now, at least I'm not closing the stream for now, at least. I want to do something at least. So what we've pretty much done this whole stream right now is that we have, currently we have made, technically, we have made one file, and that's it. Shit. But yeah, that's probably going to be so. Okay, I'll have to figure out. Soon I'm gonna go down and eat some dinner. But yeah, then we have to figure out what the fuck we need to do then. Now. APCI. What is that actually? Advanced Programmable Interrupt Controller. Woo! It's the updated Intel standard for the older PCI. Yeah. PIC, which is the Programmable Interrupt Controller. It is used in multiprocessor systems. Woo! That's probably not something that we need for now. At least. But actually maybe multiprocessing could maybe be something. Okay, so we have a few things that we could do. We could delve down into the lands of the virtual file system. I know, scary. And we could get mounting points to actually work. Yeah, fun fact: mounting points doesn't work currently. Yeah. So we could get those to work. Another thing we could do probably. Fun fact is to get processes and start to do multitasking. Make this a multitasking operating system. What else could we probably do? No, not UEFI. We could make some more system calls. We could of course do that. Oh, we could write graphics drivers, actually. And that's one thing that we could. We could write a graphics driver. Yeah, that's also a thing. We could write the. Oh, we could actually also. One thing. This is also kinda in correspondence to what's it called? This is kinda also related to the VFS. Because the VFS, of course, is just a abstraction layer over all file systems. So we could add, for example, exFAT, ext, for example. What we also could do is to add our own file system. That's another way we could do it. We could actually, let me just write down a list of things that we could do. More files systems. More file systems. What else can we do? We could do processes slash multi tasking. Mounting. That's not fucking how you would write it. How did? Oh, mounting people. Mounting points. We could try to get a SoundBlast 16 driver to work. We do graphics. Graphics driver. Not just BGA. Talking about BGA. VESA, I do believe it's called. Modes. So we can get more pixels. I think it is, for example, right now, currently we have a resolution of. What resolution do we even have? Writing and reading, reading and writing. Let's see. I think I selected mode 1, which is not even an 80 column. Actually, maybe that is. Yeah, I think I picked mode 2, an 80 column. But yeah, so we can get more. Then what must that then be? That must then nearly be 640 by 480 in a resolution. What else could we do? I don't want to do more with memory. We have done enough memory for the day. One thing that we also could do is to do USB. We could more PCI drivers. That kind of also goes under with the graphics drivers, so we kind of need to do that if we need to do that, and also with Sound Blaster. So that's how we're gonna end it for today. For now, for now at least. With a list of things that we could do. And we probably also should do at some point. This one is going to be quite hard. Like, either we need to go ahead and like I think I'm only going to use this for until we like go up to like long mode or up to another stage of a kernel, kinda, or until we get graphics, actual graphics, and so we can fetch like information about the screen and whatnot. So I think it's this one that we're gonna do. So I think we're gonna do this. Then we should also do this. We'll see about that. We'll see about it. I need to go up and get some dinner. I go and get some dinner. See y'all. I'll put you guys on. Be right back. I'm back. Okay. Need to catch my breath real quick. Okay, another thing that I've just thought of when I was eating dinner. Because yes, I also think when I'm eating dinner, is that first of all I probably should really quickly figure out what the fuck I want this operating system to be. What do I want this operating system to be? Do I want it to be like DOS? Do I want it to be like Linux? Well, maybe not Linux. Linux is a general purpose. Like, do I want it to be like DOS, aka a shell OS kind of thing? Do I want it to be a general purpose, or like that is probably a thing I also really quick need to figure out right here. But this is actually a pretty good list for now. So yeah, let's so yeah, I've said I wanted to do graphics, not just VGA. So if I want to do make anything with graphics, what do I need to be able to do that? Well, first of all, I need to. So if I want to be able to do graphics, I need to do something with the PCI. Like, that is at least the first thing that we need to do. And the first actual thing that we need to do is to look in here. Yeah, we need to do something with QEMU. QEMU, as I've also heard people call it. I just think that that's wrong. So now we have everything here. Now what kind of graphics things could we use? Maybe CPU devices, miscellaneous devices, sound devices, display devices. Now we're onto something. I really quickly need to go up there again. It was past this point. Display is this? Oh wait, that's input. Networking, storage, USB, controller, bridge, and everything in between. Okay. So let's go. Okay, let's go up here. Right here. So now we have a few things that we could do. Half of all these, I do not know what is. Let's really quickly read up on what kind of graphics should we actually do. Because I think that that's the first thing that we probably should do. Just to first of all think about what kind of graphics should we maybe do. Intel HD graphics. Intel HD graphics. Holy shit. So we can always detect it through the PCI. Always. Now redact Oh, two things. What does redact OS actually use? Run. I hope that this one is, yes, this is in shell. Great. So let's see. Oh shit. Here. Right there. Display STL. Wow. Drive, device, and device. So Vitro GPU device, PCI radio. Also just there. So yeah, let's probably throw that in, which we can do using this. And can I configure it? What things can I configure with this? I can configure the resolution of the actual device. Which right now I don't want to do that. Default 0, I'm probably just going to do that. Okay. Multifunction, okay. So now if I go under kernel drivers PCI, open this one up, move down to here. Now we have some things here already. But definitely not all. So we should probably find, like, do all of these. Right here. Even though I think it's just on the display controller, I think. That's at least what I would think here. So if I do a log debug here, and I say, actually two things. If I take all this back here, and then just put this one here, I now go under main, and then I find the PCI scan, and I say loop, press any key loop. I want to go with that. So pretty much loop until you find some, loop until we press anything. Now I have it, I've set up in a different way. I totally forgot. Subclass ID, bus, device ID. Let's just get all the information from here. Yeah, so I've made a struct for each PCI device, so yeah. So yeah, now want to figure something out about something. So yeah, what have we found? We have found a display controller at bus 0 device there. And here we can also find some other things about it. Now let's really quickly look over here and look into here. Want to find PCI. I don't want to do PCIe yet, so at least not yet. At least not yet. At least wait, what? I feel I have something up there, but yeah. Here you have it. So what do we have? So class subclass F. So what do we have? We have a class 3, we have a subclass 80, that's something else than a BGA compatible controller, an XGA controller, or 3D card. Holy shit, 3D cards! It's from a vendor. I do not know what that vendor is. Now, they also gave us a pretty good list on oh yeah, right there. 1AF4. Oh, this is listed way. But we're just gonna go search for it. Nothing. I don't know what. I just deleted. Fuck it. Oh, fuck it. But anyways, we have. Oh shit, this is actually high. Real quick. Why is it? Fuck is it so fucking high? Anyways, I should probably also turn this one a little bit more down. Right there. So we know that we now have a controller. What controller do we have? Well, we don't fucking know yet. So now we need to make a driver and try to see if we can communicate with it. Actually, I will just say else. Now we need to try to communicate with it. The way that I at least want to try to communicate with it is to list out everything the PCI has given us about it. Now, when I say it, I mean, of course, the device, because we don't know anything about it. The only thing that we have gotten is these numbers and one of these three header types. Headers here. That's it. So now let's try to see if we can list out everything about this. Starting all with, and again, just list everything. Actually, let's. I think I have a piece of hair in there. I forget. Like, do I have it? Sometimes I hate having long hair, but if I cut it, I'll pretty much get thrown out the family, pretty much. Let me see. Why do I okay, fuck it. Close. Now let us really quickly do make a function here called print PCI device. Let us give it our PCI device. And let's think. I know it's hard to do, to think, but let's try to do it. That went fucking everywhere. So, how I think I want to really quick structure this is like this pretty much. Where I have a row, some rows of something. So let's start out with the device and the vendor. Device ID and vendor ID. Now the status then, and then there is command. Status. Want everything to be capital. Holy shit, that was a great breeze of just air right there. And then the command. The class code, the sub class code, progif, and do have a, yeah, we did have this revision ID. I can't even remember what the fuck that is. Class ID, subclass ID, progif, revision. Okay, let me really quickly make this window a little bit bigger. Actually, I already, for fuck's sake, I already have it over here, this whole thing. So yeah, the cache line size, latency timer, half of all this is probably redacted or not used anymore. But hey, I don't fucking care. Cache, latency timer, header type, and you. And now we need to think about what header it is. Woohoo! So if it's 2, if it's not 2. Okay, so think it goes from 0 to 3, from 0 to 2, I guess. So let's state that if the PCI device dot, not device ID, but the header type is 0, which is this one down here. And yes, I was correct. Then we want to use header 0 right here. Right here. Now again, I am going to nil do it as like this, somewhat. Holy shit, my fucking screen is light. So yeah, let's do this. So start from here and go down. These three, we can actually pretty easily do those by saying log debug module bar. Here I think I want to have it in hex probably. And here we want to say PCI device. Go back down here, copy these, paste them in, and just like this. Now again, this is 32 bits, so we want to probably say 08. I do believe it's like this, at least. Saying, yeah, put 0, put 0, at least to pad it to 8 with 0. That's pretty much what this syntax tells us. It tells it to do. Of course, we could also do it here, but hex, it just looks better with hex. Like this. Of course, 0 hex. Now, that one was actually also together with the, could actually also have been going together with these. Again, 08x. And these ones actually don't need to be dots, they need to be, oops. That's one thing that I really quickly missed a little bit. So header 1. I can't actually remember, these ones are not pointers if I'm fully wrong. Yes, I was not fully wrong. Just like this. Now that one is also its own, and we'll have reserves. Oh, fuck. My back. My back is somewhat sometimes killing me. Somewhat sometimes. Great English beyond. Now I want to use this for everything. Pick this one up, there, and there. And that's pretty quick. Now, I don't want to list out the reserves, so this one is going to be a lonely thing. Right there. Right there. Now I have 4 of them. That's more than I've ever done. Right there, right there. We're going to close you down. Minimum something. Interrupt pin. Interrupt line. And now we have all the information. Because I don't think this has anything else in it, pretty much. Let's then call this function right here. Let's give it the PCI device. Over here, make run. And let's see if I fucked anything up. That could actually be fun. That could actually be a little bit classic for me to just fuck anything up. Let's see. Here, yes, it had header number 0. So yeah, we can see a few things about it now. Some of the things we already know. Status, actually there's some of these that I've forgotten to do hex. I've wanted to do hex. We can see the bars here. The base address something. Bus card. ROM base address. This didn't really give me that much information, to be honest. So let's now search it up. So yeah, what was actually called? Let's first of all search it up here on OS dev. Right here, we have something here. To guess VMs to be normal. Yeah, that's about correct. Some memory mapped registers. Interface allows virtual machines to assemble virtual devices. Kinda like. Okay. So based on the PCIe's subsystem ID, the I/O mapped registers for the device can be determined and all devices have a common header block of registers. Okay. You know what? We are really quickly going to go into redacted because I do not know what the fuck it means by all that. Yeah, init device. We will give it it's being given an actual device, a common config, some other things. What's this common config? Feature selected. Okay. Maybe I should go to another. Let me just try a different one real quick. Yeah, because I think this dude is using VMware. If I'm not fully mistaken. Why should I fucking run? Oh damn, QEMU, come on. Yeah, VGA VMware, yes. Didn't you have graphics? You had graphics, yes. Show me where you get your graphics. QEMU run. Kernel. Standard there. Is this just using standard VGA? That's impressive. I wouldn't do that. Testing there. Oh shit. I think didn't you also have a graphics thing or what? Minecraft? Okay. Let me see here. Scripts. Maybe I should check on that first. QEMU. Packaged. What shit that's a. Yeah. AHCI. Okay, so. Oh. Actually kind of smart. Okay. Yeah, no. Yep, no. And funny enough, I'm not gonna check the fucking Linux kernel. Because that's a freestanding thing. It doesn't have a just run function. But we could probably actually check out some of the drivers maybe. If I can find them. Modules, I do believe it was under. Nope. Configs, debug, DMA. Mapping, okay, nope. Yeah. CPU. Pit. What the fuck? Okay. That's something. You could certainly say that that was something. It's probably under IO maybe. I don't know fucking half of all of this. Where do you keep your drivers? Fuck. Where do you keep your old drivers? For fuck's sake. So yeah, we have a few ones here, I guess. Okay, mostly what I want to be able to do is to get information about the screen down to us here, down to us mere mortals. Because I don't think at least I can just poke the screen and just say, give me a fucking information. That. I don't think I can just like actually can I poke the screen? Like just poke the screen and just screen print screen font, scalable screen font. Print the screen without DB. Holy shit. Printing something to the screen. Yeah, I already know all of that, so okay, how to get screen info specs OS dev usually always gives pretty good. Receiving monitor capabilities. Yeah, that's what we want. I found the wiki and forums extremely helpful on well, the official method is to support ED extended display identification. Sounds formal, yes. Which, if I would guess anything, is yeah that's in the fun buff. That's in there. You could technically do that and just throw all the information to over to the kernel. However, setting bad modes won't damage LCD monitors. You can use the Windows approach, set a mode, and wait 15 seconds for the user to tell that it works. Oops. What? It's holy shit. Windows, for fuck's sake. This isn't as easy with bootloaders. You can decide on mode that you should support by all monitors, or you can load from a configuration file. Okay. So if I should do anything, at least what I hear here, is I should do VESA. Support VESA like modes, which I also think I've actually also written here, yeah. VESA modes to get more than this. Which I guess then maybe. But we don't really like get any kind of like VGA controllers per se, which is kind of what has stopped me from doing that. But using like VGA could actually be a good idea. Then I will actually have to then just figure something out. Okay, let's go into main. Let's then this is after all the initialization. Okay, so we'll take from here. Now, so when we switch a mode, when we switch modes in VGA, set mode, we need to think a little bit. Again, hard to do. It is doable by some people. I don't know if I can. We need to think a little bit. Because I have at least selected a few modes that I have extracted pretty much from the bootloader and up here to the kernel. Now, each of these is can be detected to either be text or graphics, have colors, the resolution, and the bits per pixels per byte. BPB, yeah. Pixels per byte. Which if I ever want to do something that's like kinda in the neighborhood, I should probably do this one. 640 by 480 with 4 pixels per byte. 4 bpp. That means that we have in total, I do believe then we have in total, yeah, isn't it then? Yeah, we have 2 pixels per byte. And we can configure the ranges ourselves if we want to. Actually, shouldn't that be mono as because we only have 1 byte per pixel? A pixel per byte? But yeah. Switch to mode yeah. 13. Let's then grab all the information here. And now we need to then wait. I mean, what was the original mode that we had? 40 by 25. 40 by 25? That's mode 1. Oh, that was something I do believe. But anyways, mode 1. Was not at all just about to forget to do semicolons. So now we're here. You might ask then, what now? Don't delete that, please. Thank you. What now? What can we actually do now? Well, we can put a pixel. We can clear. And we can actually the initialization we have already done, pretty much. But let's try to put a pixel. We don't actually have that. Oh, right, yeah, that's because that everything needs to go through this before anything. Yeah, that is how I've made it. Don't ask. So yeah, we have set palette, set color, get color, set mode, initialize. We don't have a set put pixel. Let's make one of those. VGA put pixel. Let's then say. Now, what should we then say? In the graphics, we're saying X, Y, and then color. Let's just do that too. X, Y. And here we pretty much only need a. Because isn't it the color index we're using? Or is it the actual color? Yeah, it's the color index that we're using. So yeah, we can just use an 8 byte thing there. Just in case we're gonna do that. Now, VGA. VGA graphics. Put at X, Y, and then the color. So that is the only thing that I should check if what mode we are on. Else you'll have to do it yourself. And maybe I need to actually make it visible to people and things alike. So put C, put color. That is now the official the most amount of arguments now nearly. So 0, 0, and let's set it to color 1. I'm actually impressed that the stream hasn't crashed yet. I'm actually a little bit impressed by that. Okay. Now when we press anything here, we'll go into the mode and we should see a pixel up there actually. Right there. Load VFS, of course, yeah. Boom! We got some lines and pixels and whatnot. Maybe we should really quick do a clear before we do anything. Yeah, maybe. VGA. Clear screen. Even though I think we should also do the clear screen here. Actually, do we? Yeah, we do. Fuck it. Selected mode. This will just go ahead and do all this. Enable video output. And the buffer here is good. Let's actually really quick check the logs real quick. VGA mode. Oh, that is not the correct thing. I can already tell you that is not correct. For VGA mode 13. And I just fucking praised that the stream, oh, for fuck's sake. Of course. Of course, why not? For fuck's sake. Okay. Okay. New theory. Why the fuck there's things there? What do we actually reset it with? With color 0. That means there all should be one color throughout it all. But it ain't. And let's just for now just do this. And in here we say put kind of want to be able to actually make graphics just so we're not stuck in text mode all the time. And you need to have a reference. You guys need to have a frame of reference right here on what we're talking about. Oh, 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 we got something! We got them fucking got some blue! Okay. Now, quick question. What if I say put 4 BPP here? Because I have a feeling that something ain't working as it should. Let me just yeah, set pixel, put 4 BPP. Let me expand here. Yeah, we're using a byte offset. Let's see if this matches out. No, it does not. VGA mode dot width, and that should just be it. No shit, we had lines. So now it should technically work. with only 1 pixel. Else we'll have to like go in and do some shit with the configuration and whatnot. With the configurations and whatnot. I know we still have that amount, but that can maybe be because that we just don't scale it, and QEMU just don't scale, I guess. So what if I make a for loop going 100 pixels across, saying I here, and saying I presents 16. It was not run now, it is just run. So what if we say this? Because technically now nope. That is curious. So we are saying 100 across. Put pixel graphics, put pixel, put 4 BPP, BPP, bytes per pixel. Let me just say get that so we don't have to do this one. Things. Okay, I'll try this. I'd love to if I had a mode to do 8 with 8 BPP, because then it's just 1 byte. Then it's just in with that 1 byte, and actually, do I have 1 BPP? It should not be 1. Huh? Okay. I'll guess so. We have one with fucking 8, 14. We are now doing fucking 14, mode 14. Let's see if my bad code can reach up to that address. Let's see if my code can reach up to that address. I hope. There's graphics. It has 8 BPP, bytes per pixel. Which then means that we need to change this one to be 8 also. Offset. I first of all really quickly want to do index first, and then we can do all that other shit and test it and whatnot. So again, we are going 100 pixels across on the y-axis, and we are displaying 16 colors. I actually fucking did it. Let's count them. So we have, I think it's actually easier for me to actually count over here. Because here the pixels are bigger. But anyways, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 there. 32, 64, 48. This doesn't look promising. 48, 39, 31, 2. Okay. 52. Okay. Alright. What if I really quick do go ahead and do this? What will you then say? Let's do this. Oh yeah, at least we have the whole thing across now. So yeah, there is a lot of pixels here. I don't want to count them all. Yeah. We at least now have pixels. But now what about downwards? Going down. What about there? What do we do there? What do we do with the drunken sailor? What do we do with the drunken sailor? What do we do with the drunken sailor early in the morning? Hey. Alright. Okay. Wrong thing. Wrong keyboard. Shortcut. Okay. I don't believe in that this is 200. I just don't believe in it. I don't believe in that this is only 200. That's 200. I just no. Do you know what I will say? That's probably more like 16 down or something. So it has probably something to do with something to do with the pixels and height and all that within VGA pretty much. Because if I were to do this in, let's for example say in what's it called, in the bootloader, what's it called, then it would just work fine. But here we are not working fine. Let's see, what thing is that? That's that one. Color registers. Maybe it has some. Right. Nope. Data. Nope. Okay. Damn it. Extra registers. Don't think that has anything to do with it. Screen disable. Okay. What is this? This sequence registers. Okay, so that could actually maybe be something. Synchronous when 0, this bit commands the sequencer to synchronously clear and halt. Bits 1 and 0 must be 1 to allow the sequencer to operate. Okay. Disable screen. Memory plane enabled. Enable. Characters. Sequence memory mode register. 4. Extended memory. System. Okay. Nothing there. That is the CRT. Actually, maybe the CRT has something to do with it. Maybe. Offset register. Wow. Width slash pixels per address, memory address size times 2. where width is the... This field specifies the address difference between... Okay. Double word, divide memory address, clock by 4, underline location. Don't give a fuck about that. Mode control gesture. Address warp. Divide memory. This contains the 0 of the start and the upper 8-bit okay, fuck that. The start address field specifies the display memory address of the upper left pixel. Upper left pixel, okay. Or character of the screen, because the standard VGA has a maximum of 256k of memory, and memory is 32 bits at a time. This 16-bit build is okay. Don't really need that. Maximum line gesture. Does this maybe have something? In text mode, yeah, no. Just like in text mode, no. Overflow gesture. Retrace gesture. This field specifies the end of the horizontal retrace period, which begins... Okay, I don't know what the fuck that means. Horizontal total. Specifically the number of characters clocks per scan line. Okay. Graphics registers. Set/reset register of this. This field is used by write mode 1 and write mode 3. See write mode field. I'll come back to that. In write mode 1, okay. Logical operation, rotate count, read map select, okay. Write mode 0. In this mode, the host data is first rotated as per, then the enable/set set/reset mechanism selects data from... Oh, okay. Miscellaneous sets the region and does some other things. Color, don't care. Huh? Okay. Attribute registers. Okay. Okay. I think I'll definitely really quickly read through these at some point. For now, I've now been streaming for 4 hours now. I'm fucking goddamn tired, so I will see you guys later. At some point. Probably tomorrow. Yeah. See you all at some point. Goodbye.